I will talk about the Tuenti journey to microservices. It's somehow similar to the talk, Java talent talk. It's a different view. It's maybe a few more years. My objective there is, we started as a startup. We have done a long way, done lots of things. Probably some of you may be able to recognize yourselves in somewhere and have a chance to see what we did, what did not work, what did work, and maybe you have ideas on how it could have been done better. So let's frame that journey. Initial startup, that was a long time ago. That's now. It's quite different. That's lots of people. The idea here is not talking about people, talking about microservices. But in fact, everything is about people. So let's see what's there. We started as a social network, quite well known, and we had a single real objective, and that was to grow. That was the mantra for everything. Everything had to grow, and things were growing faster than we could support it. So the big issue was scalability. What are we now? Does it work? Yeah. So now we are a mobile operator that's totally different. It's reliability is the most important thing. People is paying every month to use our service, and it has to work. It's mostly mobile, no more. There's only a bit of web, and we have to grow. It's a business, everybody has to grow. But the problem to solve is very different, the people is very different, and we've done that on the same platform. It's something that has evolved. How can this be done? Let's see what we did. Okay, we started as everybody, as the way it makes sense, the monolith. What's this beast? It's a single code base. It has, last time I saw on the two last incarnations of Mercurial, there are previous one, more than 250 committers. That's lots of engineers, opinionated people with very different ways of doing things, so that's a big issue. Execution and process, everything had to run very fast. The focus of this monolith is scalability and optimize for response time. So the monolith is great because you build it and then you just throw iron. You have everything running on the front ends. You need more, you put more of those. No big issues on how things coordinate themselves, how communication is done. You put more front ends. You have issues, you add mem caches, you add more of them. You can add database clusters, that's standard. All of us are doing that, that's the classic thing, and easy, and it can grow quite fast. Those green boxes, they were probably, 500 of them, SQL servers, some hundreds, and mem caches as well, and it works. But there is issues. So it's easy that the complete dev environment is in this repository. You can see everything. You can refactor as needed. You want to change something, just use grep. So that's great. It's scalable, it's fast. Doing integration testing, acceptance testing is easy. You don't have to do very complex things. But it has issues. Stabilization is hard when you have lots of committers, coders, and branches. Some of you have been there and know how hard it was. Release process is complex, and stability is a big issue. If something goes wrong, your full company is down. So that's bad. Okay, there is ways to mitigate that before doing the jump, and that's what usually is being tried. You can mitigate with good practices. We built quite a few interesting things to be able to deal with those issues. The base stuff that everybody does, clear layer separation. You can do that in that big monolith. You can have some part that have your JavaScript, database access, HTML in the same PHP file, and you can start building the other parts in a proper and better way. You can partition farms, so not everything goes down if something is broken. You can add lots of login. You can do fine control of the features. It's not, I mean, that's something with microservices. You can shut down things and stuff. You can do that in the monolith. Another way to mitigate those issues are process and tools. So we built Tbox. That's something that allows you to have all the dependencies of the monolith. That's a big issue with monoliths, that they have lots of dependencies. You can have that in a virtual box with Vagrant and all Puppet running there and setting up the stuff. That's quite scary. Just the same thing, we are running it now on a Docker. And you can have Flow. Flow was huge for us. It's the tool we built in-house to manage all the pull requests that were happening on this big monolith. And it allowed us to go from 2 releases a week to several a day. And without lots of work from a release manager that just does it now part-time. OK, is it enough? No, we know that it's not when you reach some issues with reliability. I mean, there is as far as you can go with this mitigation. Code ownership, you can mitigate that with, I mean, deal with that with culture, but it's very hard. It's very hard. People see code, see things that are not that good, and maybe they lower their quality level. And complexity. This monolith is something awful in terms of complexity. The big thing there is that it's very hard to throw away things. So you start building over the years. You build lots of proof of concepts, lots of MVCs, lots of stuff that you shut down. Lots of them don't work, but somehow you delete a bit of them, but there is some remains there, and that adds complexity. So what are we talking today here? Services, microservices, that's the direction. So it was called since the 90s, so that's what we knew we had to do. So let's go to the typical ways to get there. Full rewrite, that's what all us as engineers want to do. We want to rewrite it the proper way with the things we know now. But you should never do that. Netscape knows, and it's always a bad idea. I've seen startups almost die. I mean, very successful startups almost die because of that. I was on one that the CEO was brave enough to kill a project that lasted for 2 years, and that saved the company. Task extraction, that's an easy thing to do and quite natural. So there's something complex you have to do. You don't want to do there and write it somewhere else, like BI, like sending emails. And there is entity extraction. That makes sense. You have to do a big change on how session is done, how customers are managed. Let's build it somewhere else that will be better. Or just go outside. If you have new features, build them outside of this monolith. So what we did? We started with the entity extraction. We started that as a mostly engineering idea. You may think you don't need buy-in from management. I mean, management be aligned to that. So that's something that you can do. So we started with that. The general idea is to do the same with independent services. Something that you may assume is, well, let's make sure that we don't lose anything. Everything we have in the monolith, we should continue to have that, and let's prepare for that. Let's build everything needed to do this stuff. And that wasn't a good idea. We lost lots of time doing a dependency system for PHP, building a discovery service, lots of things that weren't that common in PHP, and that we thought we had to build that stuff because we didn't want to lose anything. So everything that was already there was lacking something. So that's the thing. You have your classical architecture, and you start slowly adding external services for some entities. It's not hard. It's not painful, but it's slow and doesn't really change things. So what's the next thing? We had Tuenti Mobile V2. That was a big thing. I mean, it's V2 because there was a V1 that was built inside PHP and was when we weren't a full operator, so we were using telco nodes from Movistar. So because of a business reason and a technological reason, we decided that we wanted to be the telco in an app, and you can do that not having the core network. So we started a huge project to have all these telco nodes in-house in our data center, all these 3 letters and 4 letters acronyms. We had to learn a lot. It was a very big project, lots of project management, lots of vendors, a complex thing. Management was on top of that, and we had the courage to say that these new things, we're going to build them in a new way. At the end, it was partial because we had to get to deadlines. So we decided to go to this microservices, services architecture with a Java code base. We had to rethought lots of things, but we decided quite early that we could afford losing things we had on the monolith. Because we had a different goal, and the goal was reliability. So that's what we think. It continues being quite classic because we have the big monolith there with all the stuff, and on the other side we have Java application servers. There is something not that nice about that. They have a name that you can recognize. You can talk about other engineers that AS3 is down. So that's pets versus cattle thing. There are still issues there, but it worked. I mean, we had code running there, working very well for the telco purposes, and some code running on the old monolith. We had somehow databases separated. Some services shared them, but we could track better what was going down. I forgot, we are not talking about Cloud VM here. We come from an old social network that has lots of iron, as we saw on one of the slides. We are a telco with lots of big telco boxes in our data center. We have circuit switch links that go directly to our machines. So we continue on the data center. So those are physical machines that have this new way of building things with services. A great thing about that is that Mexico came, Peru, Ecuador, Argentina, and it was easy. We could have more of those things. So an important thing there is that we decided to lose things. That's important thing that allowed us to do this jump. We had missing stuff that was given for granted for engineers that were working on this other system for years. Storage strategy wasn't that polished. Disabling didn't work that well, and the release tools were not that good. So was it worthwhile? Yes. The main thing is that it wasn't needed. I mean, if your architecture changes, maybe the tools that you thought in the past that were very important are not important anymore. In fact, it was more stable. We had independent releases. Releasing is way easier, so you don't need all these extra tools. We could use different language. It's more stable. That was one of the big things. And it's easier to try new things. One of the things that happened quite fast is that it was a no-brainer where to build new stuff. There was a question previously on how, in none of the talks, how people decide where to build new stuff. It wasn't enforced. It doesn't if you provide a better way to do things, a better place to do things. So, are we okay with that? Were we okay with that? Not really. Teams were more in control, but not really in control. There was lots of dependencies. We couldn't fine-tune reliability of each of the components. It's better, but there are still issues. There's issues that we weren't thinking about them, but with all the Docker and Kubernetes initiatives, is something that comes up. We weren't really thinking about the execution environment. We were building a software engineer software in a different software architecture, but it was deployed the same way. I mean, there is SRE systems, people that prepare environments, and you put your code there, and that creates big dependencies on how you can try new things. So here came containers. Containers just were exactly the thing that we needed. At first approach, it looks like a VM. You can do everything. You have everything isolated. Even in containers, it's less isolated. The important thing is that the VMs were managed as physical machines. They had names. They had systems people with the root password that were preparing them. There was Puppet. There was lots of awful things. So with containers, we can. The important thing is that the deliverable from engineering people includes the environment. So what's the very important thing about that is that we can use software engineering principles. That is something that has been already talked a lot in SRE, all the SRE initiatives. This goes further as it goes directly to the engineering teams. So you can have the construction of all of these deliverables that include also the environment is a software and alongside the software. So it can be versional, repeatable, documented. You can manage the dependencies, and you can release the full environment as you release software. As often as you release software, the same way you release software, and deciding for each service how you want to do, what makes sense to release. So that's where we are. Recapping, this one. Our Kubernetes cluster is Docker, Kubernetes, our core OS. It has been, we have talked a lot about that today, so it's quite classical in that sense, a bit different because it's on premises, so that's why we choose core OS. So what's the current status? We have everything. So we have the monolith, we have services and microservices running on PHP or Java farms, we have microservices running on Kubernetes farms, and we have, all the extra infrastructure, services, lots of it running on Docker, including point of presence servers we have in different countries in LATAM. That's an overly simplified schema of what we are. The amazing thing is that the migration from those Java farms to those Kubernetes farms is happening very fast. So we deployed our first Kubernetes services 2 months ago or so. We'll probably have everything deployed on the Kubernetes and kill the Java farms in a couple of extra months. So that's great. We have decided not to migrate the monolith to Kubernetes because we want to suffer when using it. Okay, and then we have POPs, that's machines that as a telco we need on different countries in LATAM, because we are, especially for our VoIP product, latency is key. So those are Docker without Kubernetes machines where we can deploy lots of different stuff. So, important thing, how we work now. So the important thing is that microservice can be designed, test, built, deployed by a single person or team, choosing, being able to choose most of the things they need. The only stuff we still have tight control is on these external load balancers. So we have tight control on what's available from externally. So build and test. That's, besides developing the service and designing it and doing everything that has to be done every time you do software, you have to build your component as for the deliverable being a Docker image. So for that we use Dockerfile. We use also an Maven plugin from Spotify that is quite useful. We don't use Kubernetes for the test and dev environment. We use just Docker Compose because it's easier. You don't need this quite messy Kubernetes platform to be set up. And with Docker Compose, we can set quite complex scenarios, especially testing network stuff. And then we use an old tool we built in the past for the monolith to test stuff in Jenkins, but we had added a new platform that is called Docker, and I hope it's the last one to run your stuff. And then this same person or team can deploy and monitor it. What are the tasks that they have to do? They have to commit, as we saw in the previous talk, the service and replication controller definitions that goes to Git, and and then it's deployed with kubectl. That's a bit raw. The thing with Kubernetes, as we saw, is that it's very new. It was 2 months ago. It was very different from now, and we haven't seen enough tools to do that properly, but it's very promising things that are happening. But right now, we deploy that with a kubectl command to production. And then with this same person or team can define dashboards in Grafana, Kibana, alarms in Cabot, and they can fully have control of their service or their lots of services that they may have. Okay, we talked about the dependencies, and we want teams to be independent, especially from platform, not needing systems SRE to set up new dependencies in production in the testing environments. What about them? The good thing is that we have seen that the operations load has gone down a lot, so they can focus on having those Kubernetes platforms working better, being on more places. They can design better overall monitoring, because we have seen in the previous slide that the team defines their alarms, their dashboards. There is something that we have seen is that some teams may not be monitoring or alarming that well, and it's very useful to have minimums that every service has to deliver. So we can have general alarms, making sure that response time overall for everybody is below a threshold, or put that in a blacklist or things like that. They can do capacity planning, and they can work on the network. We are a network operator. The network work is huge. Okay, so that's our current status. The last steps have gone very far. We have decided to go in that direction, Kubernetes, even if everything was not ready, if tools are rougher. So there's lots of things that are pending. It can be called technical debt, or it can be called going fast and then catching up. So the important thing is we have to complete migration. We don't want to have lots of different solutions running at the same time. We need better tools. As I said before, everybody's having the same issues, and there is lots of very good tools in being developed now, so that I'm sure that in 3 months things will be much better. The monolith won't be migrated. That's a decision, and we have to work on cloud, but it's not our first priority. We don't like the monolith. We want it to die of starvation. So things we're doing and this entity extraction approach, but looking at the things that are in between of the most basic flows is working on the API. We saw also on the Job and Talent API talk that they still have the API on the monolith. We do as well, and that's the first thing that we want to extract. I mean, the next thing we want to extract. And we have to work a lot on microservices interactions. Well, the PubSub, the boost that Job and Talent described is something that we don't have in a good way, and that's important. We have talked before about circuit breakers. We have put those on the most important part, but it's a very, very important concept. Another stuff that can be done to have more solid microservices is having the info in different places and then having proper mechanisms to have that in sync. We use something from telco. It's for provisioning. Usually in telco, there is these complex provisioning mechanisms to have the service on these 3 letters and 4-letter acronym boxes. Contract testing is something that mitigates the issue that doing full integration, acceptance test is hard. It can be dealt better with contract testing and distributed tracing. We have seen that a couple of times today in the different talks. Is something quite useful. We have something very basic, and we want to improve there. And then more isolation. We haven't talked, today we haven't talked much about state because it's awful. So not dealing with state is easier, but it's something we'll have to work in. And next, new versions of MySQL have better, not isolation, but ways to monitor separately the logical databases. We will be working on that. And then partition, being able to partition our different countries in different physical hardware. So that's also helping on our first goal, that is reliability. So the conclusions I took from all this process is well, the first one is making sure that you use fully the power of small teams. We have seen some tools to be able to empower these small teams. We have seen processes. Culture is an important thing. We have seen software architecture patterns to deal with that, and now platforms to empower those teams. The important thing is that everything has to be aligned. If you miss one of those, probably you won't do you won't get the full benefit. For sure, do not discard the monolith. If you're a 3-person building a startup, having to grow very, very fast before the money finishes, don't deal with that. Just function calls are great. And also something I want to talk is being too early to adopt stuff. Probably with the culture we had 5 years ago in Tuenti, it will be impossible having a platform in production that we have Kubernetes 1.1, not 1.2, but 1 year ago there was nothing of that. So it's quite crazy, but sometimes it makes sense, and that's something that each company has to assess. That's it. Any question?
How do you, for example, manage that with the kind of people that you surely need at Tuenti, which is people who like to play with the latest technology and all this kind of stuff?
Okay, so yeah, very, very good question. The thing, one important thing to do that was that it's something that was requested by some engineers in some teams. There was talks about that, and top management wanted to go in that direction. So the way from top management we did to be able to get there or get somewhere that could make sense is that we built a squad. I mean, it was one person from SRE, one person from the server core team that was building all these internal tools, one person from one of the teams that is building the business logic. They were selected with care. So that we let them for 2 months just research stuff and propose something. The way it worked is that once they were ready to propose something, the ideas had already permeated on all those teams. So it was done. I mean, it was important, and we did it carefully. Okay. Thank you.